Hi, my name is Madeline Wallace, and today I will be presenting a report on grizzly bear population monitoring in the greater Yellowstone ecosystem. My research topic is based on data collected by the Interagency Grizzly Bear Study Team, which is responsible for monitoring the grizzly bear population in the greater Yellowstone ecosystem. Each year, the team releases an annual report that provides information regarding their findings. This project focuses on observations of female grizzly bears with offspring. This leads me to my research question. I am looking at data collected over 2 decades of observing female grizzlies with offspring to estimate population growth. My research question is as follows. Is the mean litter size of female grizzly bears in the greater Yellowstone ecosystem increasing in 10-year increments from 1998 to 2008 and 2009 to 2019? This slide contains my null hypothesis and alternative hypothesis. The null hypothesis states that the mean litter size of female grizzly bears in the greater Yellowstone ecosystem does not differ from 1998 and 2008 and 2009 to 2019. The alternative hypothesis states that the mean litter size of female grizzly bears in the greater Yellowstone ecosystem has increased from 1998 to 2008 and from 2009 to 2019. Also listed on this slide are the symbolic forms of each hypothesis. All of the data was previously collected by the Interagency Grizzly Bear Study Team by means of aerial surveying. Each observation flight consists of 2 rounds of observing radio-marked female grizzly bears with offspring. This slide contains the descriptive statistics of each set of data. As you can see, each group contains the mean, standard deviation, and 5-number summary. Continuing with the descriptive statistics, this slide provides the bar graph for the data collected from Group 1. As you can see, the data in the graph varies and skyrockets in 2008 when the litter size peaks for the decade. And this slide contains the bar graph for Group 2. You can see here how the litter sizes plummeted after the boom in 2008. They then start to build up again, eventually peaking in 2015 and then falling again. Moving on, each interval for confidence level and upper and lower limits are listed here. I went with a 95% confidence level for this project, indicating that I am 95% confident that the total number of female grizzly bears observed with offspring from 1998 to 2008 ranges between 12.06 and 18.66, while the total number from 2009 to 2019 ranges between 22.05 and 35.65. These intervals do not overlap, which implies that the total observations significantly increased from 2009 to 2019, enough to gap the intervals from the previous decade. A one-tailed left t-test best suited my data, in which the test statistic came out to 3.6354. Because of my 95% confidence level, I chose a significance level of 0.05. This granted me a p-value of 0.0005, the results of which indicate that there is a strong evidence to support the alternative hypothesis and reject the null hypothesis, since the p-value is less than the significance level. In other words, I can assume that the null hypothesis is invalid, as it is highly unlikely that the grizzly bear population to remain the same over the last 2 decades. It is more likely for the mean litter size and therefore overall population to increase, which is supported by the statistical and contextual evidence. In conclusion, I can say with certainty that the data presented in this report supports the claim that the mean litter size and population of grizzly bears is on the rise. All statistical evidence provided in the earlier slides provides sufficient evidence in favor of my alternative hypothesis, proving the increase in population of grizzly bears in the greater Yellowstone ecosystem. And here are my references. Thank you for listening.